Hey everybody, my name is Nick. I'm a math educator with over 20 years of in-class math teaching experience, and I make videos on this channel at First Coast Math Clinic with the goal of helping you increase your enjoyment and understanding in mathematics. And if you have difficulty solving and checking any of the equations you see on the screen in front of you, stick around because in this video I'm going to show you how to solve and check equations with variables on both sides. Let's get into it. All right, let's start with number one. So we've got 9x plus 24 equals 12x. And I'm going to write our steps and goal off to the side as we solve this. So our goal we know is to isolate the variable. Which in this case is x. And let's go through our steps to solve. So our first step is we want to combine our like terms. Across the equal sign using inverse operations. Now we know from previous videos that inverse operations are operations that undo each other. So think like addition and subtraction or multiplication and division. And we know like terms are terms with the same variable raised to the same power. So if we're looking at our terms, we've got 9x, 24, and 12x. Of those three, which two are our like terms? Well, that's going to be the 9x and the 12x. And if our goal is to isolate the variable, we want to get that variable, that x by itself, then let's get the x's on the same side. So to do that, I want to move this 9x to this side. So my inverse operation, the 9x is positive. So I'm going to subtract and subtract 9x from both sides. 9x minus 9x cancels out, it's 0. So I'm going to get 24 equals 3x. My next step, I want to isolate the variable. Using inverse operations. So we want to get that x by itself. What's happening with the 3 and the x? They're being multiplied. How do we undo multiplication? Let's divide. So I'm going to divide by 3. Divide by 3. 3 divided by 3 is 1 and 1. If I'm multiplying and dividing by 1, I don't need to keep the 1 in there. So I'm going to get x equals 24 divided by 3 is 8. And my last step, I like to put a check in. So for our check, we're going to take our original equation, and wherever we see an x, we're going to replace the x with our value, our answer. So in this case, 8. So we're going to have 9 times 8 plus 24 equals 12 times 8. Well, 12 times 8 is 96. 9 times 8 is 72 plus 24. 72 plus 24 is 96. And we get 96 equals 90, not 99, 96. So the left side and the right side equal to each other, are equal to each other, so our answer checks. All right, let's get into another example. Okay, so for number 2, we've got 5x plus 7 equals 8x minus 8. So our first step, we want to combine our like terms across the equal sign. So let's just identify what our like terms are here. So same variable raised to the same power. So they're going to be 5x and 8x. That's one set of like terms. And 7 and 8 are our second set of like terms. So I'm going to start by combining the 5x and the 8x first. So I'm going to move the 5x from the right side to the left side, or from the left side to the right side, excuse me. There's a couple different first steps that we can do here. I'm going to show you how to solve this 2 different ways. So 5x is positive. I'm adding it. I want to use inverse operations. So I'm going to subtract 5x and subtract 5x. 5x minus 5x cancels out. It's just 0. So I'm going to get 7 equals 3x minus 8. Now I want to combine the 7 and the 8, right? So again, I want to get the x by itself. So let's move this 8 to the left side because our goal is we want to get the x by itself. Well, what's happening with the 8? 8 is being subtracted. So to undo subtraction, I'm going to add 8 and add 8 to both sides. Negative 8 plus 8 is 0. And I get 15 equals 3x. Let's undo this multiplication. Divide by 3. Divide by 3. We divide out and get 1 and 1. We don't need the 1 there, so we're just going to get x equals 5 as our answer. Okay? Now let's solve this a different way. So I'm going to rewrite it over here. So 5x plus 7 equals 8x minus 8. So there's 4 different possible first steps that we can do and solve this, and no matter, as long as we do that first step correctly, we're going to get the same answer. So let's combine maybe the 7 here and the minus 8. So what I want to do is I'm going to move that 7 from the left to the right. So reading this from left to right, 7 is positive. It's being added. So to undo addition, I can subtract 7. Subtract 7. Positive 7 minus 7 cancel out. I've got 5x equals 8x minus 15. All right, because here we're dealing with signs. So really quickly, if I do this over here, negative 8 minus 7. Using our subtraction rule, this is negative 8 plus negative 7, which gives us negative 15. Now, get rid of this. We want to combine the 5x and the 8x. So I'm going to move the 8x to the left. So our 8x is positive. Let's subtract 8x and subtract 8x. 8x's cancel out. 5x minus 8x gives us negative 3x equals negative 15. Remember to keep our signs with our terms here. So now I want to undo this multiplication. We're multiplying negative 3 and x. Let's undo that by dividing by negative 3, dividing by negative 3. Negative 3 divided by negative 3 is just 1, so we don't need the 1 there. Negative 15 divided by negative 3 is going to give us a positive 5. Whenever we multiply or divide the same signs, sign of our answer is positive, and we get the same answer both ways, okay? So we solve this 2 different ways and got the same answer, x equals 5 and 5 equals x, right? So let's do our check here. So taking our original equation, 5x plus 7 equals 8x minus 8. Let's replace the x with 5. So we have 5 times 5 plus 7. So we get 25 plus 7 and 40 minus 8. And then we get 32 equals 32. So our answer checks. All right. So again, we should do 2 different ways to solve this equation depending on your first step, and then we checked our answer, checked our solution at the end. All right. Let's get into example number 3. And so for number 3, we've got negative 9 minus 6x equals 5x plus 13. So let's start by combining our like terms. Again, our like terms here, let's identify those first. So we've got the negative 9 and the positive 13. And let's do this in green. We've got the negative 6x and the positive 5x. So what I'm going to do is I'm going to start with the 9 and the 13, negative 9 and 13. We know we want to get the x by itself, so let's move that 9 to the right side. 9 is negative, it's being subtracted, so I have to undo the subtraction and add 9. Add 9 to both sides. Negative 9 plus positive 9 cancels out. So I get negative 6 equals 5x plus 22. Now, to combine our x's, we have to move the 5x to the left to get the x's by themselves. So 5x is positive. So let's undo adding 5x and subtract 5x. Subtract 5x. 5x minus 5x cancels out. So we'll have negative 6 minus 5. So we can think of our operations with signs. Like, kind of get rid of the variables for a second. We can rewrite this as negative 6 plus negative 5, and we get negative 11x on our left side. So now getting the x by itself, we can divide by negative 11, divide by negative 11. The negative 11's divide out to 1, so we don't need them, and we get x equals 22 divided by negative 11. We're going to get negative 2 as our answer. Now again, I want to solve this one more time using a slightly different first step. So divide this out here, and we're going to have negative 9 minus 6x equals 5x plus 13. And let's start by maybe adding the 6x to both sides. Actually, not the 13. I'm going to do like terms. So let's deal with this. So let's work with the negative or minus 6x and the 5x. So I'm going to bring the 6x to the right. 6x is being subtracted, so I have to undo subtracting 6x and add 6x to both sides. So the 6x's cancel out on the left, and I get negative 9 equals 11x. We'll circle out the variable there. 11x plus 13. Now I've got to move that 13 to the left. So let's subtract 13. Subtract 13. 13 minus 13 is 0, cancels out. Negative 9 minus 13 gives us negative 22, and we get 11x on the right side. Now we can divide by 11, divide by 11, and we get x equals negative 2 as our answer. So we get the same answer both ways, no matter what our first step is. All right, so let's check this. So we get negative 9 minus 6x equals 5x plus 13. And let's substitute negative 2 in for x. So I'll have negative 9 minus 6 times negative 2 equals 5 times negative 2 plus 13. So negative 9 times negative 6 times negative 2 is positive 12. 5 times negative 2 is negative 10 plus 13. Negative 9 plus 12 is going to give us a positive 3, and negative 10 plus 13 is going to give us a positive 3 also. So our left and right side are the same, so our solution checks. All right, let's move on to example number 4. Okay, so for example number 4, we've got 2x plus 8 divided by 3 equals 2x. So we've got a fraction on our left side that we've got to deal with first to get our variable by itself. So I decided to kind of, our steps can be a little bit different here, but I thought it fit well in this video, because these are examples you're going to see when you work on multi-step equations or equations with variables on both sides. So our first step is we want to get get rid of this fraction basically and get rid of that 3, right? So let's think of what operation is occurring here. In any fraction, what are we doing with that denominator? We're dividing by the denominator. So how do we undo division? we're going to multiply. So let's multiply by 3 on the left side and multiply by 3 on the right side. Now, I'm going to write this out on the left side. So this is basically 3 times 2x plus 8 over 3 equals 6x. So on our left side, we have 3 in the numerator and 3 in the denominator. Well, if I have 3 in the numerator and 3 in the denominator, I can basically just divide those out and get 1 and 1. All right, and if I multiply by 1, divide by 1, nothing's going to change. All right, multiplying and dividing by 1 doesn't change anything. So on my left side, I'm left with 2x plus 8 equals 6x. All right, so we got rid of our denominator by multiplying both sides. The important thing is that value is going to cancel out on the left side. We're going to multiply on the right side. Now we can solve this as we normally would. Let's combine our like terms. So the 2x and the 6x. I'm going to subtract 2x, subtract 2x. 2x's cancel out, and I've got 8 equals 4x. Divide by 4, divide by 4. 4 divided by 4 is 1 and 1, so I don't need the 1 there. So it's going to be x equals 2 as our answer. All right, let's do our check up here. So take our equation, 2x plus 8 over 3 equals 2x. And wherever we see an x, let's replace it with 2. So 2 times 2 plus 8 over 3 equals 2 times 2. Now in our numerator, 2 times 2 is 4, plus 8 over 3 equals 4. 4 times 8 is 12 over 3 equals 4, and then 12 divided by 3, and we get 4 equals 4, so our answer checks. All right, let's get into one more example. Okay, so for our last example, I decided to put an example with some fractions in. So we've got 1/4 x plus 1/2 equals 3/4 x minus 1/4. So let's start by combining our like terms. I'm going to start with the 1/4 x and the 3/4 x. So I'm going to subtract 1/4 x and 1/4 x. So our 1/4 x cancels out on the left. So we're going to have 1/2 equals 3/4 minus 1/4 is 2/4 x minus 1/4. So we have the same denominator, so it makes our math a little bit easier. I'm going to keep this 2/4 for right now. We can reduce that, but I'm going to wait until we kind of get to the last step to really reduce everything. So now let's move this 1/4 here from the right to the left. I'm going to add 1/4 and add 1/4. 1/4 cancels out on the right. So now I've got 1/2 plus 1/4. So let's do that up here. 1/2 plus 1/4. Common denominator is going to be 4. So I can keep that 1 over 4. I'm going to multiply this by 2 over 2. So this becomes 2/4. And when we add this up, we're going to get 3/4. So we get 3/4 equals 2/4 x. Now to make our math a little bit easier, 2 over 4, we can simplify that to 1/2, right? So 3/4 is equal to 1/2 x. Now if I want to get the x by itself, we know that we can divide by 1/2 and divide by 1/2. So I'm going to do the rest of this math up here. So we have 3/4 divided by 1 over 2. To divide our fraction, we could change it to multiplication. So we've got 3/4 times 2 over 1, giving us 6 over 4. And I'm going to keep it an improper fraction for right now, just to make our check a little bit easier. So divide by 2 and divide by 2, we're going to get 3 over 2 as our answer. So x should be 3 over 2, okay? So for our check, which I'll do up here, so 1/4 times 3 over 2 plus 1/2 equals 3/4 times 3 over 2 minus 1/4, right? So I'm substituting in my value for x and x. I'm substituting 3 over 2 and 3 over 2. Now let's multiply straight across. 1 times 3 is 3. 4 times 2 is 8 plus 1/2. 3 times 3 is 9. 4 times 2 is 8 minus 1/4. So let's get some common denominators now. Well, what can I multiply 1 over 2 by to get a common denominator of 8? I can multiply this by 4 over 4. So this is going to become 3 over 8 plus 4 over 8. So this gives me 7 over 8 on my left side. And on the right side, what can I multiply this by to get a common denominator of 8? Well, I can multiply this by 2 over 2. So I've got 9 over 8 minus 2 over 8. And then 9 minus 2 gives me 7 over 8. So my solution checks. So I have 3 over 2, or if we want to write that as a mixed number, right, I'll do that over here. So I'm running out of room. We know dividing 3 by 2, 2 goes into 3 one whole time with 1 left over. So we should get 1 and 1/2 as our answer as a mixed number. So I want to show you another way that we can solve this equation and really not have to deal with the fractions at all, right? We notice that our denominators are 4 and 2. So what's our least common multiple for 2 and 4? Well, that least common multiple is going to be 4. All right, so we know that's our least common multiple, or our common denominator, for 4 and 2. So let's think about this. Well, what happens if I take this right side and multiply it by 4? Right, so I've got 4 times 3 over 4x minus 1/4 times 4. Well, what's going to happen with 4 and 4 and 4 in the numerator here and 4? They're going to cancel each other out. So the 4's cancel out, 4's cancel out, and on the right side, I'm left with 3x minus 1. All right, so we got rid of our denominators by multiplying the right side by 4. Well, in an equation, whatever we do to the right side, we have to do to the left side. So if I multiply the right side by 4, I have to multiply the left side by 4. So let's do that out on the left side. So I'm going to have 4 times 1/4 x plus 4 times 1/2. So 1/4 of 4, the 4's and 4's cancel out, so we're left with 1x plus 4 times 1/2 is going to give us 2. So our equation went from 1/4 x plus 1/2 equals 3/4 x minus 1/4 to 1x plus 2 equals 3x minus 1. All right, so our equation's a little bit easier to work with now, right? So let's go ahead and solve this. I can subtract 1x and 1x from each side. 1x's cancel out. I get 2 equals 2x minus 1. Let's add 1 and add 1 to each side. 1's cancel out. I get 3 equals 2x. Divide by 2. Divide by 2. And I get x equals 3 over 2, which is what we had when we solved our equation using with fractions, or 1 and 1/2. Okay? All right, so another way that we can solve this equation by kind of getting rid of our fractions by multiplying by our least common multiple on each side first. So this video was on solving equations with variables on both sides. I went through 5 different examples on how to solve and check equations with variables on both sides. If you like this video, leave a like, comment, and subscribe. This is Nick from First Coast Math Clinic.